Hello and welcome to another tutorial on dev.java website, and we are looking at creating, initializing and accessing arrays. And we said that arrays are built-in type. You declare an array by setting the type, either primitive or class type, and then the square brackets. And after that you have to define the array or tell the compiler how many elements are in the array. And the way you do that, you say that my array is equal to, you use the new operator, and then tell the compiler how many elements are in this array, right? If it's primitive, the compiler looks at the type of the array and then allocates enough memory. For example, int is 4 bytes, 10 times 4, so the compiler allocates 40 bytes for the data elements in the array. But then we said that arrays are objects. In Java, arrays are objects, unlike C or C++, so there is some extra header. For example, arrays have a field that has the length, keeps track of the length of the array. So the total size of the array that the compiler allocates in Java heap is more than 4 times 10 here. For example, in this case, it's not 40 bytes. It's a little bit more because the JVM or Java runtime has to keep track of some properties of the array. And also arrays are subject to garbage collection, so they have some extra logs. And I believe you can also synchronize on the arrays because arrays are also objects or treated as objects. So there are some sort of built-in objects. So one way to create an array is with the new operator, right? We know that in Java, everything is new. Everything is allocated on Java heap. You can never allocate on Java stack. JVM in its own discretion can sometimes allocate local variables or local stuff on the stack. It's called escape analysis. And there is really not much documentation about escape analysis, but that's one of the optimization that the JVM can do if it deems that that's a good optimization, and that typically only happens for local variables. So the next statement in the array demo program allocates an array with enough memory for 10 integers. And again, Java guarantees that integers are always 4 bytes or 32-bit. That's why we already know that the size of the elements, the total size is going to be 40 bytes. And assigns the array to an array variable. So we already declared this variable. I told the compiler that this is an int array, and now we are creating the actual array, and it's going to be empty. Java language specification guarantees that whenever you create an array, all the elements are going to be default initialized, which means all the bits for each element, all the bits of that element is going to be 0. So int, we already saw that the default value for int, if all the bits are 0, is 0 integer. If it's line, it's 0 line. If it's reference, whenever you have a reference or pointer that all the bits are 0, it's interpreted as null. So everything is going to be null. And we will look at example of this kind of reference arrays. If this segment is missing, if we declare the array but don't initialize it or don't use the new operator, then the compiler doesn't actually know how many elements are in the array. So the compiler says you've never initialized it, which means the compiler is telling you, you never told me how many elements are in the array, right? Because when you declare something, you just tell the compiler what the type is. So let me go back to this array, and let me also create a new package and then move this. So dev.java arrays, we had a package for variables and primitives. Let's move these two into arrays. Okay, and then okay, it's going to refactor them. So in this array, we said that if you look at the main, we are declaring the array. We just tell the compiler this variable, whenever you see this, it's referring to an array type of type integer. But then we have to actually initialize or define. So definition versus declaration. Declaration, you just tell the compiler whenever you see this symbol in the source code A1, it's this type. And whenever compiler gets to this line, it takes a note of the type of this variable A1 based on the declaration. But then after that, you have to actually also define the array, which means now you're telling that this variable that was supposed to hold an int array is now holding 3 elements in its int array, right? And the compiler says that, okay, the types match. This on the right hand side, you are telling me to create an int array. On the left hand side, this variable is actually declared to hold an int array, so the types match, so there is no type mismatch. And then now you're telling me that allocate enough memory in the Java heap for 3 int elements, which is fine, totally fine, right? But then the compiler also guarantees that it's the elements are going to be default initialized, which means if I don't initialize the elements and just quickly after creating the array, I immediately access the 0th element, the first element, it's going to be 0, which means the default value was put in this array, right? Now we said that for the reference types, I can do the same thing, a string array A6, right, equals a new string array. Remember that a string is an object, and any type of object, you can also create an array of that object. The difference here is that, and I'm going to emphasize this again, a string array is an object, is treated like an object, and we said that you can never subclass any basically array type. You can, for example, never subclass any like a string array. Now you can't even subclass a string because a string is final, but if you have like object, you can always subclass object, but you can never subclass object array, right? So basically you can subclass object, but you cannot subclass any array type, object array, right? So just I want you to make sure that you understand this, and or maybe let's just comment this out and say that you cannot subclass any array because there is no class definition associated with it, right? And we can just comment this out. So a string array A6 new, this works fine, but we said that the array elements will be default initialized. Which means that the compiler allocates the memory and makes sure all the bits are 0. Default initialization means for each element all bits are 0, and here we're talking about references, which are the syntactic sugar for pointers. And whenever you have a reference or pointer, all the bits are 0, it means it's a null pointer or null reference. So if I just do a sysout A6 0th element, it's going to print null, as you can see, which means A6 index 0 is going to return a null because we never initialize it. Now obviously we can initialize this with, let's say, hello, right? Now the first element is initialized, the second and third element are not initialized. So hello, right? So let me put this next. So null reference, initialize the reference. So we initialize it and we access this again. And this one should work fine, right? So I want you to understand the difference between a primitive array type and a reference array type. Both are supported. And then the idea here is that reference arrays, the default values are always null. So be careful about that, because then you get some, if you are not careful and you're not fully initializing it after defining it, then you run into null pointer exceptions, right? Which can be a little bit of painful to deal with. So you have to tell the compiler how many elements are in the array, and then we are just initializing by accessing each individual index. We said that that's the only way, and if the number of elements is large, then you have to put it in some sort of loop. Each array element is accessed by its numeric index. So we said that a square bracket, which is called a subscript operator or index operator, is working for both for assignment and also accessing, basically write and read. So you use the index operator or subscript operator to access read and write from the array. We said that in C or C++ we also have the pointer notation, right? You can use directly, because the reference or the name of the array is actually a pointer to the first element. So you can use the pointer math, pointer notation, dereference for the assignment, etc. But in Java we don't have this kind of stuff, so we just read and write to the array using the index operator. So alternatively, you can use the shortcut syntax. So we use an initializer list, or basically as soon as we declare the array, we also initialize it. And again, we looked at this and we said that the trick here is that the compiler will infer the length of the array. So you cannot basically define the array and then try to initialize only the first few elements. That doesn't work. For example, if I use this notation with direct initialization, the compiler will infer that the length of the array is going to be 6. If I do this, and we said that if you try to use var, you have to explicitly tell the compiler what the type of the array is, and then you can also provide initializer list. The length here, you cannot provide any length. Let's say if I say 5 here, this doesn't work. So the compiler doesn't allow you to specify the individual elements and also specify the size. So the compiler forces you to only initialize, and then the length is going to be whatever you put here, right? So here the length of the array is determined by the number of values provided between braces. These are called initializer list. You can also declare an array of arrays, also known as multidimensional arrays, by using 2 or more sets of brackets, such as a string array. Each element therefore must be accessed by a corresponding number of index values. Now in Java programming language, a multidimensional array is an array whose components are themselves arrays. So it's an array of objects. So a multidimensional array, really, you access each element by the index, and each index returns a reference to an object, because at each index there is another object, which is an array whose dimension is 1 lower than the original array, right? So if you have a two-dimensional array, and I say names index 0, it returns the first row or the first array, because two-dimensional array is a one-dimensional array of arrays, right? That's how Java handles this, and that's the reason that each element can be an array and the length is not necessarily the same. So there is no restriction that if I have a two-dimensional array, it has to be a square dimension, which means all the elements have to have the same dimension. Java doesn't have this restriction. That's just because the way Java treats two-dimensional arrays or multi-dimensional arrays is that each element by itself is a reference to or a pointer to another array, right? In Java programming language, a multi-dimensional array is an array whose components are themselves arrays. This is unlike arrays in C or Fortran. So the reason is that in C or Fortran, they force, because of the way that the caches work in the CPU. In C or Fortran, the array is a contiguous block of memory if you allocate on the stack, even if it's a two-dimensional array, right? The compiler handles the index operator and how it works on the multi-dimensional arrays. You don't need to worry about that. But then what the compiler does is that if you define a two-dimensional array in C or Fortran, it will be laid out as a one-dimensional array in the memory, right? Either row major or column major. These are details. Usually C handles two-dimensional arrays or multi-dimensional arrays as a row major, so it lays out each row after each other. In Fortran, it's usually column major, so Fortran lays out a one-dimensional array with the first column and then second column, etc. And the reason that they try to handle multi-dimensional arrays as a single contiguous block of memory is because of the access efficiency. It's much more efficient to know to have one contiguous block of memory, even for multi-dimensional arrays, because then accessing them is very fast. A consequence of this is that the rows are allowed to vary in length. So the way Java handles, again, multi-dimensional arrays is that the rows or each element in a two-dimensional array doesn't have to be the same length. A consequence of this is that the rows are allowed to vary in length, as shown in the following multi-dimensional program. So we have a two-dimensional string array, and we can look at this example. So let me create a new class, multi-dimensional arrays. Let's have a main method. Okay. So what do we want to do? First of all, let's look at the example that they have. We have a string array. Let me just copy and paste it. That's fine. And we are using an initializer list to directly initialize this. So as you can see, the way we initialize a two-dimensional array is like this. So let me just write it down. Let's comment this out. S1 is. So we put one pair of curly braces. This is initializing the entire array. Remember, a two-dimensional array is just an array, right? So this is an array of objects. What objects? The objects are a string array, because we said that in Java an array is treated like an object. So I can have obj1, o1, o2, etc., right? And each element is already a string array. That's how Java treats this. And then there is no restriction that how many elements each one of these objects can hold. That's why we say that if I have a two-dimensional array in Java, there is no restriction on they all should have the same length. That's not how Java handles arrays, right? So let me put this at the top here. And then so these braces are for initializing the entire array. And now what goes between these braces is initialization for each element. So this is O1, right? And the way we initialize O1 is again with a pair of curly braces, and then another curly braces for O2, and we can continue, and the compiler will infer how many elements or how many rows are in there, right? So that's how this works. Right now this is an empty array, so if I say sysout s1, it's going to give me the type, which is an array, right? So what is the signature in the bytecode? The signature is a multi-dimensional array, an array of objects, right? And what are the objects? The objects are one-dimensional array. So, and the signature of a array in bytecode is a square bracket. And then so a square bracket L semicolon for a Java object signature, and the object is Java lang a string, right? And then we don't have, then we remove these. So it's an array of objects. Each element is an array of object, and then we put these arrays together to get the two-dimensional array. So the signature is a square bracket, which means we have a two-dimensional array, and then the elements, the inner elements are L semicolon that indicate that we're holding references to Java objects, and it's Java lang string, right? Semicolon. So note that L semicolon is the signature for a Java object. Now if I define a int two-dimensional array I1 equals and then this first row, second row is an empty array. Let's terminate with semicolon and look at the I1. What do I expect the signature to be? The signature is going to be a two-dimensional array of integers, right? So there is no L semicolon because these are primitive types. Let's run these. As you can see, we have a square bracket I, which indicates integer. If I say, for example, double, I should get a square bracket capital D for double. If I say float, I should get capital F. So a square bracket F, etc. Right? So long is represented. So basically, the primitive long is represented with J. A square bracket J. So maybe let me just quickly also tell you the signatures. Usually when you write your Java code, source code, you don't care about the signatures. If you try to use Java native interface, then you have to know about the signatures. Int translates into I, and then basically long translates into J, and then short translates into S. Byte translates into B, I believe. Char translates into C, and then Boolean translates into Z, and then float translates into F, and then double translates into capital D. And any object type translates into L semicolon, and in between that we put the fully qualified name, qualified class path name, right? So this is how the signatures work in the bytecode inside the JVM internally, and the qualified class path name, we know that in the source code the delimiter is dot. Inside the JVM or in the bytecode, the delimiter is always forward / right? So you replace dot with forward /. So let's try that. We saw that I signature is so int signature is going to be I, and then long is going to be J, yes, and then short is going to be S, capital S, yes, and then byte is going to be capital B, yes, and then char is going to be capital C, yes, and then boolean is going to end up with capital Z as the signature, yes. The reason they're not using capital B because they already use capital B for byte, and they're not using two letters, so they have to use one letter. So instead of using something like BO or something, they just decide to go with Z. Float becomes a capital F, yes, and then double becomes capital D, yes, capital D, and then any object, let's say object for example becomes L semicolon, so it becomes L semicolon, and then the fully qualified name, and the fully qualified name object is in the Java lang, Java/lang/object. So L semicolon starts with L and ends with semicolon, and Java lang objects. And note that when they print it, it actually prints dot, but inside the JVM it's actually /, right? So if you're using a Java native interface and trying to find a class on the class path and create an object, you have to use /, and then the signature is L, starts with L, ends with semicolon, and then Java lang object. These are like Java objects, signature of Java objects on the class path, right? And then yeah, this was a brief detour about this, but let's say now how do we initialize this? So I want the first a two-dimensional array, the first element is an array. I want it to have 3 elements, right? And then the second one, I want it to have 2 elements, something like this, right? So if I print this out, remember we are printing the reference. So the 2s string, the way the 2s string works, we are calling the 2s string on the S, which inherits from the object itself. So let's do a sysout s1.2s string. Remember that s1 is treated as an object, and array is treated as an object, so it inherits from the object class, inherits from object class, just like any other type. Although there is no actual class definition because the implementations of the array is internal inside the JVM itself, but the 2s string still works as the default, the 2s string implementation in the object. And if I open it, you see it goes to the object class and then calls the 2s string here, and they're just getting the hash code to hex string, etc., right? But then how do I print the elements as a string? You have to use arrays class. This is a utility class from Java util, and we will look at this in the next lecture. Arrays.toString, and then you pass your two-dimensional array reference. What this does, this, if you call the toString on the two-dimensional array, it goes through the array, each element of the array which is supposed to be an object, and calls the toString on that on each element. So if I run this, let me run this. Now you see we get an array of and the signature is basically so let me just write. So the way it prints it, it prints a square brackets to denote arrays, and then comma o2 to a string, etc., right? So it creates it goes inside each element and calls the toString on each element, which is supposed to be an array. That's why we're getting the first element to a string is array of a string, the second element array of a string, right? So this is not what we want. So we want a deep to a string. A deep to a string means basically go to O1, and then for each element of the O1 call to a string on each element, right? So O1 index 1 to a string, right? So this is the first element, which is an array, and then we can do this the second element, etc. This is called deep to a string. Deep to a string, which means it recursively goes into the elements and tries to call them. So we say arrays deep to a string, and you call it on an object array, which is S1 in this case. And as you can see, now we are getting the toString on each element of each row, right? So that's how this works. This arrays has a lot of utilities for dealing with arrays. Another topic that I want to discuss is covariance. Now you say that, okay, and the way the types work, we know that we have in Java, we have this instance of operator, right? So let's see, if I have a int array a1, right? Let's make, or let's new int with 3 elements. We said that arrays, one-dimensional array is treated as an object, right? So let's say var x1 is a1 instance of object, and sysout x1. Obviously, instance of returns a boolean. So the type here of the x1 is going to be inferred as a boolean. So I could use var or could use boolean. So the question is this true or false, right? And we know that this has to be true because a one-dimensional array is treated as an object, and we already know that because it definitely inherits from the object class. So this is going to be true. So one-dimensional array inherits from object, so it's instance of object. So int array a2 is new int, and the way we initialize a two-dimensional array, let's say 3 rows, and each row or each element has 1 column. So if you go with a new operator, unfortunately in this case all the elements, if you try to use new operator with a two-dimensional initialization, all the elements end up having the same length, and this is not necessary. We said that if you go with the initializer list, there is no reason. The other way is to just go with so you can initialize a two-dimensional array with a one-dimensional notation like this. This is not correct, but if I let the second index empty, this means that we have 3 rows, but we don't declare the size of each row, right? Right now each row is an null reference, so I can say a30 equals, and now I can actually use an initializer list, for example. Can I do it? No, but I have to call the basically new operator, new int. Let me see. So a30 right now it's going to be int array, right? Each row, we say that we have 3 elements in this array, which means a0, a1. So basically we have this a3 is like index 0, index 1, so O0, O1, O2, and each one of these is supposed to be an int array, right? But we didn't declare the actual size of each one of these. So, and right now each one of these is a null reference, so we can say O0 is new, or basically a3 at index 0 is new int, and then now we can specify the size, or we can directly initialize it, 1, 2, 3. So this works, and now the next element a3 at index 1 is -1, -2. As you can see, I created a two-dimensional array, but I didn't specify the size of each element. Why? Because I want the flexibility to have different lengths or different size for each array element. Now if I do a deep to a string, arrays deep to a string on a3, the first element is going to have 3, the second one is going to have 2 elements, the third one is still null because it hasn't been initialized, so we should see a null. Yes, so this is the first element, which is by itself is an array, and we had to use the new operator and specify either the size or use an initializer list. And note that we cannot omit this because the only time that this notation works, a direct initialization, is when you are declaring. So declaration and initialization together, but we are not declaring this variable. This has already been declared using this definition, right? So we have to explicitly use the new operator without the size and use the initializer list. So the first element of this two-dimensional array has 3 elements. The second one 2. The third one is still null, right? So again, initializing multi-dimensional arrays is usually not straightforward, especially if you are dealing with reference types in this case, because each row is already an object. And make sure that you always try to initialize everything beforehand, otherwise you end up with null pointer exceptions down the road, and that's very tricky. So each array, one-dimensional array, is an instance of object. What about a two-dimensional array? Let's say this A3. So Boolean x2 is A3 instance of object, and this is also going to be true, x2, because even a multi-dimensional array is by itself is an one-dimensional array of objects, right? So no matter how many dimensions your array has, it's still going to inherit from objects and be treated as an object, right? Yeah. Now what about basically Boolean? When I have a multi-dimensional array, we said that each element is itself an array. So each element instance of object. Each element of a multi-dimensional array is going to be also instance of object. Let's see, true, yeah. So what about if we go through inheritance? So what about array inheritance? So let's say class 1. I have class 1 here, and then a new class 2, which and this class 2 actually extends class 1, right? And now let's look at the array inheritance. Array inheritance. How does this instance of works from array inheritance? So let's say I create a class 2 array, one-dimensional array, and then a two-dimensional array, right? And then or maybe so let's say we create a class 1 array. Let's say C1 is new class 1 array. All right, let's say with 3 elements. This is typical. We can use any type. And then can we use polymorphism here? So let's say C1 at index 0 is new class 2. And this works. And we could also initialize, directly initialize. So class 2 C or class 1, this we initialize with 2 elements, new class 1, new class 2. Remember, class 2 inherits from class 1, and there is no problem here. Basically polymorphism works. Polymorphism works with arrays as well, right? So in the future lecture, we look more into details of the array, this type of arrays, polymorphism. We also look at this arrays class, which is very important and has many utility class. So please stay tuned, and I'll see you in the next one.